Impact of a moving load on a beam and creation of a line of influence of a moving load. As article number 212 from the book Mechanical Systems Calculations of the Marine Facilities. Sometimes when the issuers of the mechanics of statics is doing so, the question arises that one had to find the stress translated to find the support reactions and find the balance equations of the mechanical systems and the influence of the moving load, which can change the point of the application. To do that, the method is the creation of lines of the influence of the factors. Factors can be the support reactions, the bending moments, and the shearing forces on the location of the point of the application of the moment. For example, we have lines of the influence of the place we characterized by the variable x relative to the reference point A for here, for example, for indefinite one sample. And we can find the lines of influence, the dependence on for example, the magnitude of the support reaction in the hinge B is a sliding hinge, and the hinge, another support hinge A is a fixed hinge. The reactions in the supports in dependence on the location of the point of the application, point location X, point application of the unit force P. So, and as well, not only for the support reactions, as well for the bending moments and as well for the shearing forces, they can be assured to determine. The lines of the influence are not the diagrams of the bending moment and shearing forces, because all other factors like displacements of the elastic beam, like angle of rotation of elastic beam under the influence of the external load. No, but the lines of influence are dependent not on the constant load of all the beam, but dependence of factors in the definite one point. For example, in this sample assigned the point K on the influence of the moving load. So first of all, we can, according to in the issue of this definite one sample, to find the lines of influence of location of the point of the application of a force on the magnitudes of the reactions of the supports RA and RB. To do that, we have to consider first the balance equations. For example, considering the balance equations of the rotation of the unit force and reaction around the point A, we can find that the support reaction, we have the balance equation of the equivalence of zero, the total of the moments rotating the beam around the point A. Two forces rotate. First force is the reaction of RB by the arm L, and another force rotate unit force P by the arm X. So we have arm L of the application relative to the reference point A of the reaction in the support B, and we have X as arm of the point of the application of the moving load. In definite one point, this variable, so the point can be other this like moved. So we assume this X like the variable, and we have the balance equation with one unknown variable, and we can see that the reaction RB depends on this variable linearly. It depends like RB is equal to X divided by L. Yes, and if X equal L, we have that RB is 1, exactly, yes, but if the point of the application of unit force is here, B, So the reaction have to be, RB to be equal to the unit point 1. And from the equation, and when we have the point of the application x equal to 0, we need only 2 points of the magnitudes of the support reaction to have the linear dependence of support reaction on the variable point of the unit force application. And after the considering this balance equation, we remind that the point p is equal to 1, so we can just exclude it from the equation is equal to 1 product 1 by x is equal to x, so we have the RB equal to x divided by L from this balance equation. And the second point, when x equal to 0, we have the reaction RB equal to 0, so we have the line of influence of the location of the unit force on the support reaction in the second one, support B. And if we do the balance equation around the second support B, it have to be equal to 0. We have two moments, moment of the unit force and moment from direction on the first support. From the first support we have with a minus sign because reaction of the first support rotate around the point B clockwise. The unit force is counterclockwise, and the arm of the application of unit force relative to the point B is P product by the L minus X. The rest part of the arm is L is a span between the supports, minus X is a distance from the line of action point P to the hinge B. So we have another one balance equation. We remind that P equal to 1, so we have from this linear balance equation that R A equal to brackets L span between the supports minus X divided by L. And next we can find that if X equal to L, we support here X equal to L, and we have that RA have to be equal to 0. Yeah, it is because if the unit force applied on the second one B support, so reaction of the first support equal to 0. No another forces we have. And if x equal to 0, RA equal to 1. So we have two lines of influences of the location of the unit force P on the support reactions RA and RB and RA. Next, we can find the line of influence of the allocation of unit force on the bending moment in the point K. Just assign the arbitrary point K in the span from the point RA and the RB, and we can find. We consider this consisting of two branches: the left branch of the line of influence, and the right one branch. The left branch of line of influence we consider from x equal in between minus A1 to A. This is minus A1 is the left end of the beam. I1 is the console size of the console part of the beam from this one part to AA from the point A. Support to the arbitrarily chosen point K. The A is a distance. And we can consider that balance have to be around the point K from the, we do the section method, Ritter method, section method. And in this definite one interval between A minus A1 to A, mk equal to 0 when x equal to 0. So when x applied to the point of the first support, the moment of the is equal to 0, because for the left branch of the influence line, and mk equal to b at x equal to L. Yes, and is this due to the application of the support direction RB got here line of influence have to equal x to L in the balance equation mk equal to RB product B. have to be, this is bending moment of direction B on the it's how it acts in the point K. So we have arm B. So RB bend counterclockwise around the point K if we have the RB. So we need to know what is RB in dependence on the location of the unit force. And we use got originally the dependence of the line of influence of the location of the point application of the force on the magnitude of the RB, support action at the point B. And using these two formulas, we have the bending moment, this one, and we can substitute the bending one moment is here. The x divided by L product by B. And when we substitute instead of x to points at x equal to 0, x equal to B, we have that the bending moment have to be equal to 0 or have to be equal, or x equal to L, sorry. We can find that during using this one formula, that this in 3 points, we can another 1 point we have the if x equal to A, we consequently substitute the magnitude of x into this balance equation for the bending moment for the left branch of the influence line. We from the cutoff right part of the beam using section method, and we find that 3 points mk equal to 0 at x equal to 0, mk equal to b at x equal L, and make mk equal to product A by B divided by L. So we have these points 0, A by B divided by L, and we have the just assumed point B, but just we do not have the line of influence because it's another one branch of the line of influence, but we just put it here just as the computation as a result of the calculation. For creation of the total diagram, we need another 1 point. We need 2 points to do the diagram of a line of influence. The creation of right branch of line of influence for the right branch of line of influence. This one is the right branch of line of influence. Is if x is from A to L plus B1, if the x from A right branch of line of influence x from the reference point is from L to plus B1. B1 is the length of the console segment of the beam. So from condition of the balance of the cutoff part to the cutoff left part of the beam, we have to substitute the reaction RA and acting on, from the left part act on the when we cut off the left part, so we have the balance of the left part. RA have to be product A is RA to the point K, we have A. And we substitute RA is dependent as we got before when we did the line of influence of location of the point of the application unit load. We had that this line is RA is brackets 1 L minus X divided by L. So here we have the proportion L minus X divided by L product by A. And when we substitute 2 points, we have from the 1 point is X equals 0. The bending moment have to equal A when at X equal L. In this one, mathematical equation, this one mathematical equation, the bending moment in the point K equal to 0 if unit force applied in the point of A in the point of L. No, this is very understandable, because if we consider the draft of the assigned beam, if the unit force applied in the point x equal to L, if the point equal to 0, if the point equal to 0 have to be equal the bending moment to A. Yeah, we can put here that the bending moment is P product A. P product A, but P is equal to 1 is a unit force. So when XL we have, because if the unit force applied in the point B direction on the point A is equal to 0, so the bending moment in the point K is equal to 0. So we have another one branch, assumed magnitude of the line of influence due to required only to do the total line of the influence for two branches together, intersected in the definite one point with the magnitude of product A by B divided by L. And we so force got the line of influence of the bending moment, determining of the left branch of line of influence of transverse force. From condition of balance of the cutoff right part of the beam, we have that the bending force equal for the left. Conditional balance of cutoff right part we have for the left. So this two lines of influence gives us the opportunity to use it in determining the line of influence of the location of unit force on the transverse force sharing this beam. These two lines of influence, one is used for the left one part of the line of the influence of the location of the point of the application unit force on the sharing force. But with another one sign here, we have a negative sign here, we have positive here, but the same magnitudes. And we have the line of influence of the location of the point of the application of unit force on the point A to, we consider the balance equation for the left part. If we need to do the right branch of the line of influence, we consider to balance equation of the right part. If you need to do the left part of the right line of influence, this helps us to reduce the number of the forces in the balance equation, because for the right part, the unit force located on the right, and that's why on the left from the point K is only the one force is support direction A. This is used for the determinant of the line of influence of the location of point of location of unit force on the bending moment in the point K, and the same as for the sharing forces in the point the point K on. So we cut off another part when consider the balance equations for the rest part. So, and the right branch of the line of influence of the location of unit force on the sharing force corresponds to the line of influence of cutoff line of influence of the right part of location of the unit force on the support direction RA. We can see that the final magnitude here B1 divided by L equal to B1 divided by L from this one line of the influence. And here we can find that as we use the balance equations to do that. For determine the left branch of line of influence of the transverse force from the conditional balance of cutoff left part of the beam, when we can find that sharing force equal minus RB equal to RB is equal minus X divided by L at in the interval of X from minus A1 to A. And we have the zero in 2 points, zero sharing force if the point of application of the unit force is equal to 0, and it is minus 1 divided by L at the point of application of X equal to L, is if X equal to L. And we have another one. We have the shearing force minus L divided by L if x equal to R. Minus L divided by L if equal to R. X equal X, variable equal to A, distance from the left support to the point K. And the right branch determinant of the line of influence of the transverse force on the transverse unit force on the shearing force from the conditional balance of the cutoff left part of the beam. We have here that the RA is brackets L minus X divided by L. We use it at the interval of X from the point K to the right. That's equal X equal from A to L plus B1. It follows that shearing force in the definite points in the point X equal to 0 equal to 1. Yes, equal to 1. This is just assumed part of the line of influence used to do the rest branch of the line of the influence. Is this line of the strokes is just only assumed part of the lines. This auxiliary help to do the diagram in the total. And Q equal to 0 when X equal to L and shearing force equal to L minus A in the brackets divided by L and equal B divided by L. B is L minus I is equal to B, yeah, divided by L. B divided by L if X equal to A. So if X equal to A, and we have the step of the line of influence. So we have the corner on the line of influence of the bending moments and the point assigned or determination K. We have as well step on the line of influence on the location of the unit force. We have a step on the line of influence of that factor on the shearing force. And determining lines of influence of the position of unit load in the console parts of the or the assigned beam, the internal forces and sections on the left of the console K1. If we can do any place here, and we need to find the line of influence or the location of the unit load on to the left from the console K1, we can do the balance equations and we can find that in the assigned intervals of the magnitude of x1 and x2 is another variables, another than the previous one we did consider for this line of the actions. We did consider x beginning from the reference point A, and to the console parts we from the consider the x from the points assigned K1 and K2, and we can find that if the force located to the left from the x1 we have the shearing force 1 line will not depend on the location of the point of the application, just only one even distribution of the shearing force independently on the location of the point of the application. And we have the line of the moment, because maximal moment is if the shearing force, if the unit force applied at the end of the beam. So to the point K, the arm is C, and the arm is gradually reduces if we move the unit force closer to point K1. The same on the right part, we have the evenly distributed the shearing force. If the unit force is to the right from the point K2, no other forces we have to the right, so this is even distribution. And we have the maximal bending moment in K2 if the force located at the end. So the distribution is like indicated on this line of the influence on the bending moment point K, etc. So this is just explaining how we can use the balance equations to find the lines of influence when the load acting on the console part of the assigned beam. Questions and comments. The line of influence of a force when moving the point of the force application without changing the direction of the force. Line of influence is dependence of the factors. Factors is like bending moment, sharing force, support reactions, or maybe the displacements of the beam, or maybe the angles of the rotation of beam under the external load and the support reactions. When the external unit force assumed moving along the beam, This is line of action. This is not the diagram of the listed factors. It's not the diagram of the bending moment, sharing forces, and the displacement balance and the angles of the rotation, etc. Because diagrams are the dependence of the listed factors on the constant assigned external load, constantly in magnitude and constant in the magnitude and in the places of the application. Next question is the load line along which a unit load moves. To determine line of the influence of the moving load on the factors in the beam, we consider unit load moving along the load line. Load line is a straight path of moving the unit load when we determine the lines of the influence of the unit force location onto the factors like shearing force, bending moments, support reactions, and maybe the displacements of the bended beam and the angles of the rotation under the influence of the external load and the listed other factors. Line of influence, next question, line of influence of the position of a unit load on the magnitude of the transverse shearing force. Yeah, we can do that considering the lines of influence of the moving load on the support reactions, because we cut off the another part and consider only part of action of the definite one support reaction depended on the which we got the line of influence before. The support reaction depends on the location of the external force. And if we have the dependence on the location of the unit force of the support reaction, we can use in the next this to do the lines of influence of location of the external force on the shearing force. And in each case, we cut off the another part to reduce the number of the factors to find the bending moment. So use method sections. So thank you.